Hello out there. So today what we're going to do, we're going to be factoring polynomials using the greatest common factor. Now, something you should know as we go forward, using the greatest common factor is what you're going to look for all the time when we're factoring polynomials. All right, I'll probably repeat that a couple of times, but it's very important that we get this lesson down. The very sad part is that I'm doing this over a video and I'm not seeing your faces, so I can see what your misconceptions might be or what you're not understanding. But anyway, let's give it a try. We're going to do what we have. All right, so first, if we start where we were yesterday or a couple days ago, if we multiply, I'm going to write this all down. Also, you'll notice that today what's happening is that your notes, you're going to be filling in, you're going to be writing in as I write. That's why those pages are bare. So what we're going to do is we're going to multiply, and the example is, I'm going to put an arrow, pretty cool, you know I do that all the time, 3x times the quantity 2x squared plus 5. All right, now what we have done in the past, we've used the distributive property to multiply across the addition, because that's what this distributive property is. So if I multiply 3x times 2x squared, that's going to give me, oh, I love all these choices. No, yes, no. Okay, so that's going to give me 6x to the third. And then if I multiply 3x times 5, that's going to give me 15x. Okay, so that concept we should have down already. What we're going to do when we factor this polynomial or this binomial is the opposite. Just like the opposite, now if I were in class, I would be asking you the opposite of addition, the opposite of subtraction, the opposite of multiplication, the opposite of division. While factoring, I like to think of it, it kind of is the opposite of multiplying across or distributive property. So we're going to go backwards. Let's write this down. We're going to go backwards. To find what number or what goes into both. And I'm going to add in terms. All right, what goes into both terms? All right, it's kind of saying, what can I divide into both terms? What number can I divide into both terms? But what is the biggest number that I can divide into both those terms? Because that's going to be the greatest common factor. All right, so I'm going to move this down a little bit, hopefully. All right, there we go. So I'm looking at I'm going to bring this down 6x to the third plus 15x. All right, so I'm going to think of, first of all, let's deal with the coefficients. All right, the numbers in front of the variables. What is the greatest common factor of 6 and 15? Well, you're going to remember from your past, you did that back in the day, very important. Well, that's going to be 3. So if I'm looking at these two numbers, coefficients, all right, 3 is the greatest common factor of 6 and 15. Now, this is the part that gets students, and I really love to see you right now and to see what you're thinking. I have to also deal with those variables, x to the third and x. Believe it or not, there's a greatest common factor there. Really simple, though. It's going to be the coefficient with the smallest power. So let me write that down, actually. All right, coefficient with the lowest power. So I have an x to the third and an x. All right, the lowest power is x raised to the 1 power. So I can factor that out. I can divide that out of both x to the 3 and x. So that's going to be, just trying to get some different, I'll do the same here. So that x and then x to the third, all right, I can factor out an x out of both of those. Okay, now here's the part that I think helps me, and maybe to help you, or this is one way. Once you see these, once you do a number of them, you don't have to do this step, but I'm going to do it for the first number or so, or maybe even all of today, so that you get used to this. So what you're really doing now, since there's that 3x is the greatest common factor of 6x to the third and 15x, what you're really doing is you're dividing that out. So if I put a division sign here, and I put 3x, and I put a division sign and 3x. Okay, so now after you take the 3x out, that comes down, the question is, what are you left with when you divide that out? So if I have 6x to the third divided by 3x, well, we know straightforward that 6 divided by 3 is 2. All right, simple enough. 6 divided by 3 is 2. Now, x to the third divided by x. Well, that leaves you with x to the second, because whenever you're dividing exponents, you subtract. So that's going to be x to the second. Bring down your plus sign. And then you have 15x to the third. Well, you know that 15x to the third, that's 15x divided by 3x, sorry. So you know that 15 divided by 3 is 5. X divided by x, well, that's just going to be 1. So that's your answer. So your answer is 3x, or the greatest common factor, or I'm sorry, factoring using the greatest common factor, the answer is going to be 3x times the quantity 2x squared plus 5. Now, math, a beauty. You can check your answer. You know how many times I say that, and you can hear, I can hear people in the class saying check, check, because that's what you should be doing. How do you check it? Well, you do the opposite of factoring. You multiply or you distribute. Okay, so when I distribute 3x times the quantity 2x squared plus 5, I should get back to 6x to the third plus 15x. So here I go. I have 3x times 2x squared. That's going to be 6x to the third. All right, and then I have 3x times 5. That's going to be 15x. All right, so that's an example of, or that's the first example of our factoring using the greatest common factor. Again, that's what you're going to always look for when you're factoring these binomials and these trinomials. All right, greatest common factor is always what we're going to look for first. All right, let's take a look at another example. So I'm going to go example number 2. I'm going to have 8x to the third power plus 4x to the fourth power. Now, what I want you to do, think of the greatest common factor, think of the variable raised to the lowest power, what you can pull out of there, and then divide each of them by each term and get your factored form. All right, so why don't you try that? Why don't you pause, try that, and then we'll go over it. So pause now. Okay, pause. Pause. All right, now you're back. So here we go. So you should know that 8 and 4, the greatest common factor between 8 and 4 is 4. All right. And then the lowest variable there, all right, or the lowest power for that variable, sorry, is x to the third. So I have x to the third, x to the fourth. So I'm going to pull out x to the third. All right, now what you're going to do, and again, if you see this, go for it. You don't have to incorporate this step. I'm just doing this to help you out, all right, because I think this is new for everybody. All right, so you're going to divide each term by 4x to the third. Okay, because that's what you're left with. When you pull that 4x to the third out of 8x to the third plus 4x to the fourth, the question is, what are you left with? All right, so you're going to divide to see what you're left with. All right, so I got so many colors here, I'm confusing myself. But anyway, so 8x to the third divided by 4x to the 3rd. Well, you know, these are going to cancel. All right, so you're going to be left with 2. Bring the plus sign down. All right, so if I have 4x to the 4th, and that is divided by 4x to the 3rd, well, the 4's are going to cancel, and when I subtract, I'm going to be left with just x. Now, I know some of you are asking, oh, is that the way I leave it? Well, you can, or you can go 4x to the 3rd times x plus 2. Either one is good. All right, now, again, if you distribute, all right, you're going to get back to the same answer. Now, you may say this one's going to be first, or the 4x to the 4th is going to be further. It's addition, okay? So it is absolutely fine to leave it like that. All right, let's go example 3. Let's go on the side here. I think we have room. So example 3, that's going to be 2y squared, and that's going to be minus 4y. All right, once again, why don't you pause and why don't you try this one on your own? So go ahead. Okay, you're back. All right, so the greatest common factor of 2y, or 2 and 4, is going to be 2. So I'm going to take that out. I'm going to take out my 2. All right, and then the variable raised to the lowest power is going to be y. So I'm going to divide both of these by 2y. All right, when I divide them, again, what am I left with? Well, here I'm going to subtract the y2 minus y. 2's are going to cancel, so I'm left with just y. Bring down my minus sign, that's important. I know 4 or negative 4 divided by 2 is negative 2. And my y's cancel. So that's my answer. Again, what is the check? The check is to distribute and multiply, and you'll get back to your original answer. All right, let's see how I'm looking on space here. Do I have space for number 4? Yeah, let's do it. All right, so what I'm going to do, if you don't have space, go to the next page. I'm just trying to save some space for our work going forward. All right, I'm out of practice. All right, so here we go. Number 4. I have 40x to the 3rd plus 5x squared plus 10x. Yep, it's a trinomial. And same rules. That's the beauty of math. All right, so what I need to do is find the greatest common factor between 40, 5, and 10. Okay, well, the greatest common factor between those is 5. Okay, then step 2, again, I look for the variable raised to the lowest power because I can take that out of each one of those terms. Okay, so the variable raised to the lowest power is x, raised to the 1 power. Okay, once I do that, well, after I do that, I'm going to divide each term by 5x. 5x, 5x, 5x. Each term gets 5x, or divided by 5x. Okay, because you're taking that out of each term, or dividing it out. All right, so what happens? Well, I know that 40 divided by 5 is 8. And then x to the 3rd divided by x is going to be x squared. 3 minus 1. All right, bring down my plus sign. I know that 5 divided by 5 is 1. I know x squared divided by x is going to be x. 2 minus 1. Talking about the powers. And then 10 divided by 5 is going to be 2. And then the x's cancel. And that's my answer. All right. Now, what do you do to check? And I'm not going to do that with you. You can do it on your own, and you should. I hear you not doing it. All right. So you're going to distribute to make sure you get back to the original problem. All right, I'm going to pause for a second. You can pause, take a break, drink of water, no watching TV, but I'm going to turn to the next page. All right, I'm back. Example number 5, and so are you. I hope you had some water, you're relaxed, you're ready to go. No TV. All right, anyway, so my next example is 16x to the 5th plus 8x to the 4th plus 2x to the 3rd. So what I want you to do, I want you to try that one on your own. So pause the video and go for it. All right, you're back. So here we go. Again, I have to think of what number is the greatest common factor between 16, 8, and 2. Okay, well, that answer is 2. Then I look for the variable raised to the lowest power. That's going to be x to the 3rd. All right, now I'm going to divide each term by 2x to the 3rd, because that's what I'm going to be left with. That's what I'm factoring out of each term. I hope the more I say it, if you don't get it as we're going along, it pops. I can't see that, which is too bad. You know, I love those moments when you go, oh, now I get it. All right, so I hope that happens or is happening. Anyway, when you divide 16x to the 5th, divide by 2x to the 3rd, well, 16 divided by 2 is 8. All right, x to the 5th divided by x to the 3rd is x to the 2nd. All right, plus 8 divided by 2 is 4. X to the 4th divided by x to the 3rd is just x. And then 2x to the 3rd divided by 2x to the 3rd. Now, please don't put 0 because that is not the answer. You don't leave this blank. That is 1. Very important. Okay, now, again, what you can do, you can distribute to get back to the original. Very important to check that. You know how I feel about that. Don't get it wrong. All right, let's do a couple of ones that are a little different. Not much, just a little bit. All right, so number 6. Number 6 I have, let's go purple again, negative 10 m to the 9th. Yes, that's a 9. Plus 70 m to the 5th. All right, I've seen a couple ways of doing this. I just think the simple, or I think the most straightforward way is continue the path that we have been on. All right, so when I look at 10 and 70, I'm thinking what number, greatest common factor in both. There's a negative there, so it's not going to be 10, it's going to be negative 10. I think that's important. Different color. So I'm going to write negative 10. Again, which variable has the lowest power? M to the 5th. Let's divide that by both. All right, so stick with the same color. All right, so when I divide the first one, okay, I know my 10s are going to cancel. That's 1. And then m to the 9th divided by m to the 5th is going to be m to the 4th. Now, here's the part that you have to be careful with. And I'm going to highlight this. I'm going to give it a little highlight. All right, your signs are going to change. That's the part you just got to be careful with. All right, because 70 divided by negative 10, that's going to be negative 7. Okay, remember we're dividing this out, so all those rules apply. So it's going to be negative 7. And m to the 5th divided by m to the 5th is going to be 1. So that's my answer. Now, when you multiply, okay, across, what you should do, remember a negative times a negative is a positive. All right, so you're going to get your positive 70m to the 5th. Very important. All right, let's go for number 7. Actually, I'm going to put number 7 alongside because I want to finish on this page if I can. All right, so number 7. Back to, all right, let's go green for the number, purple for the example. So number 7 is x to the third, y to the second, and I just put 6. Sorry. Purple again. X to the third, y to the second, and that's going to be minus 3 x squared y. All right. Um, so the one that's a little different about number 7, or the point that's different about number 7, is there is no coefficient in front of the first term. All right. Well, there is a coefficient. That's wrong. The coefficient is 1. So if I'm looking for a greatest common factor between 1 and it doesn't exist. All right. Or it's 1. Anyway, so the question is, what do I do next? Well, you're going to look for, as I've been saying, follow the rules. All right, the variables raised to the lowest power. So I have x to the third, and then I have x to the second. Well, the lowest power there is going to be x to the second. So I can pull that out of both of those terms. I can factor that out. All right, and then I look at y to the second and y. What is the lowest of those variables? Well, it's going to be y. So I can factor that out also. Okay, I'm going to then, let's stick with the same. All right, I'm going to still divide. Again, rules stay the same. So I'm going to divide x squared y. I'm going to divide x squared y. Both of those terms. So for the first one, I'm going to take x squared out. So I have x to the third divided by x squared. That's going to leave me with x. I have y squared divided by y. Well, 2 minus 1, it's going to leave me with 1. That's going to be y. Bring down my minus sign. 3 divided by 1 is 3. Cool. And then x squared divided by x squared, well, that's going to be 1. And then y divided by y is going to be 1. So that's going to be my answer. My answer is going to be x squared y times the difference of xy minus 3. Again, one more time, if you were to distribute or multiply across that subtraction, you would get back to the original. And you should do that. That's really good practice. All right, let's go down to number 8. I think I have room for this. Cool. All right, I'm going to make it neat. Go across. Break it up. All right, so number 8. Let's go green, purple. I have 20. Uh-oh, that's not purple. Oh well, going blue. 20n to the third plus 12n plus 12. Okay, now what you should do, pause the video and then go for it. And then let's come back and check. So please do that, work along with me. So I'll stop talking so you can pause. And you're back. All right, so here we go. Again, greatest common factor, GCF of this trinomial, the 3 terms. All right, what is the GCF of 20, 12, and 12? I hope you answered 4. All right, because that's correct. So I can take a 4 out. Notice the last term doesn't have an n, so I don't have to worry about I don't have to worry about the variables. So I'm going to take out my 4. And then I'm going to divide each term by 4. Okay, when I do that, all right, for the first one, all right, 20 divided by 4 is 5. N to the third comes down, plus 12 divided by 4 is 3. n comes down, and then 12 divided by 4 is 3. Tree. All right, so that's going to be my answer. So one more time, if I distribute, I'll get back to my original problem, just as a check. Okay, one more. Why? The question is, why not? All right, so number 9. And they have plenty of room for it, which is cool. All right, number 9, the problem is 3ab raised to the third power. That's going to be minus 6. I wrote in the wrong color. Oops, sorry. Didn't mean for that to happen. Come back. All right, I could have paused, but I didn't because I thought that was pretty funny. Anyway, so I have 6ab. So I'm just going to go for it. Let's see, if you need to go through all those steps from before. So I'm going to look at 3 and 6. I know that the greatest common factor of 3 and 6 is 3. All right, I know that in terms of the variables, a and a, I can take an a out of both. B to the third and b. All right, the lowest is b. All right, so now what I'm going to do, I'm going to use the same color. I'm going to divide both by 3ab. I'll do this for you. 3ab, 3ab. All right, so for the first one, I'm going to be left with this cancels. b3 minus b is b squared. B squared. All right, and then negative 6 divided by 3 is negative 2. All right, that cancels, and that is my answer for now. Anyway, that's it. So a little shorter video, very little, but still shorter. All right, that is factoring using the greatest common factor. As I said to you before, very important concept. Take your time with it. There's a homework that's with it that I listed in the email. If you have questions about the homework, I believe it's page 23 or 24, whatever I listed in the homework. So let's get that done. You have to the end of the week. This is the last video of the week. So make sure you go over those concepts. Any questions, again, shoot me an email. I hope everybody's doing well. Miss you guys, and talk to you soon. Stay safe.